Hi everyone, I'm Dr. Ariel Miller, and welcome to our first lecture in the series on professional writing tools for engineers. Today we're going to learn how to use Microsoft Word's equation editor in LaTeX mode, an efficient and powerful way to write math like a pro. You might be used to clicking buttons in Word to insert equations, but if you want to write faster, cleaner math, especially as you move into research and thesis writing, using LaTeX syntax is a game changer. Plus, it makes the transition to Overleaf and LaTeX editors much more seamless. So let's talk about the objectives for this lesson. So why learn LaTeX in Microsoft Word? You're going to get consistent formatting, faster equation input, easier editing of complex math, and it will help transition to other LaTeX editors like Overleaf. So now let's go over some basic LaTeX commands that you will use a lot in your writing, in your research writing. So the fraction, which the LaTeX syntax is shown here. And when placed inside of the equation editor, will come out looking like that. You have the subscript. That's the LaTeX syntax. And when placed inside of the equation editor, you'll produce your x sub 2. You have the square root, your syntax, the final product, your exponent, x squared, will come out looking like x squared. And finally, your Greek letters. So we will be using a lot of Greek letters in our engineering and scientific writing. So if you want to write the alpha symbol, you'll use this syntax and you'll get an alpha symbol. You'll write out beta like this to get your beta symbol, gamma, and so on for all of your Greek letters. And as I will show you in a second when I actually demo how to use these, if you want the uppercase Greek letters, all you will have to do is change the first letter here, so the A in alpha, the B in beta, the G in gamma, and so on and so forth. You'll change those to the uppercase letter. And that's how the computer will know that you want the uppercase Greek letter instead of the lowercase Greek letter. All right, so let's get into some examples and practice. So I'm going to switch over to Microsoft Word. So from Microsoft Word, you can insert the equation editor anywhere on your page where you have your cursor. And it will default to center the equation, but you can always change the justification that you want. So I'm going to start off by showing you how to find the equation editor using your insert tab menu. So if you go to the insert tab here and go all the way over to the right, in the symbols column, you will see equations and symbols. And you can just go ahead and click on that, and the equation editor will show up inside of Word, inside of your Word file page. And you can see here it automatically centers it. So from here, you don't actually need to put the cursor in there. By starting to type, it will know to type inside of there. So let's start off with the fraction that I just showed you in the previous slide. So you're going to go with the backslash first. That's the one right above the enter key. And then you're going to type out frac. You're going to open your curly brackets. The things that go inside the first set of curly brackets are going to be what's going to go in your numerator. So we'll put the letter A in our numerator. When you're done with everything that goes in the numerator, you're going to close that curly bracket. And then you're going to open up a second set of curly brackets. And that's going to be everything that's going to go in your denominator. So we'll just put B in there and close that. One other thing to let you know is that mine is defaulting to LaTeX, but your equation editor might default to Unicode. There is a lot of overlap between Unicode and LaTeX, but there are also some differences. So I strongly recommend that you change your text input to LaTeX before you start. So as soon as you open up the equation editor, you can just go in here and click LaTeX if it's not already selected. So when you're done writing all of your equations, you then hit your enter key and you will see the final product. So if you have a very long equation with fractions and subscripts and superscripts and, integrals, etc., while you're typing it out, you're not going to see the final product as you move along. You will only see the final product when you press enter and do a carriage return to get to the next line. And that's when it will take you out of the equation editor. So you can see the equation toolbar is no longer there. And now my equation is fully formatted and I can go back to typing. So what this allows you to do is insert your equations, and they will look like, as you'll see as we continue on in this example, they'll look like equations that you would see in a textbook. So let's go ahead and do the exponent next. For this one, I'm going to show you the hotkey for how to bring up the equation editor without having to hunt for it every single time in your menu area. So if you press the Alt key and then the plus sign equal key, so Alt then plus equal, it will show up on its own. So that is the shorthand, the shortcut to get you to the equation editor. And you can do that multiple times, as many times as you need to insert equations. All right, so let's add the exponent in. So that's x squared. So it's going to be x, then the caret. So that's the shift 6 key to get the caret, and then 2. And that is going to give you, we press enter, x squared. Subscript. So now we'll do subscript. So this is y sub. So this is going to be shift and then the underscore button, which is right next to the plus equal sign, and then whatever you want to be in the underscore, then enter. So if you have an underscore or a superscript that has more than one number or variable in it, you need to use curly brackets. So what do I mean by that? If I say I want x to the 10, okay? You can see here, it doesn't understand that the 0 belongs with the 1. So it'll give me x to the 1 times 0. So what I have to do is I have to do x exponent, open curly brackets, then I'll type 10, close curly brackets, then press enter. Now it knows everything inside the curly brackets next to the caret belongs in the superscript. And the same thing goes for your subscripts. If I try to do y to the y sub 10 like this, it doesn't understand and it'll get it wrong. So you need y underscore, open curly brackets, 1, 0, close curly brackets. Let's now add in our Greek letters. So Alt equal again, backslash, I'll type out alpha and press enter. Show you the same thing for beta. And just for good measure, one more time, backslash gamma. And as I said before, you can type out, if you need the uppercase, then you can just make the first letter an uppercase letter and it will do that for you. So let's do backslash and let's do sigma. Okay, and I'll show you again if we do this lowercase sigma. And let's do delta because that's one that we use a lot as the uppercase Greek letter. And then finally, we'll sometimes use the uppercase gamma. So let's add that in. All right, and the last thing we're going to do here is the square root. So alt equal one more time and backslash square root, and then open curly brackets, x, close curly brackets, and there you go. And so everything that you want to be inside that square root would be inside of those curly brackets. So you can see here, this is how you would do it typing it out in LaTeX. You may have noticed when I bring up the equation editor that there's also a series of buttons in a graphical user interface within the equation editor menu that you can choose from. And I'm going to show you how you can use them, but I don't recommend them. It's why I'm teaching you the LaTeX, because if you're already typing out your thesis or your paper or whatever, it's a lot easier and more fluid for you to, while you're typing, to just press alt equal when you want to introduce an equation, type in your equation now that you know the syntax to type it in, and then press enter and continue on typing. As opposed to, let's start again from the insert equation. And if I want to type in a fraction, I would go over to the fraction and then I'd have to select the fraction that I want. So this is a stacked fraction. Now you might want to do this if you want the skewed fractions, if you're doing something in line, but let's say you don't. So now I have to click here. So now you have these two dotted boxes, and that's where you're going to put your numerator and your denominator. So we'll put the B down here, and then I'm moving with my arrow key to get it from the denominator to the numerator. Okay, and then if I press enter like this, it's not going to know to get out of there. So I have to move my arrow key to the right, which will take me back down to the denominator, and I need to do it one more time and one more time again to get out of the fraction, and then I can press enter, then I can get out of the equation editor. Or I can move my mouse to move me out of it. But these are cumbersome steps. So I'm going to hit alt equal one more time, and I'm going to show you where some of the other ones are. So you have your superscript, your subscript, if you have both a super and a subscript, which I'll show you how to do that by just typing it in, but you can press it here. And then you can have it on the left-hand side or the right-hand side. So if I want a superscript and a subscript and I want to type it in, because typing is, as I said, faster, I'd say X. It doesn't matter what order you do this in, but I'll do superscript 2 and then underscore I. Press enter. You can see here the X squared sub I. I will show you where you can find all the Greek letters. So here you have a lot of your typical basic math symbols. This is your basic math menu. And if you click on that arrow, you can get even more of them here. So you'll see you have your alpha, your beta, some of your typical Greek letters that you use. You'll have your delta here for your change of. If you hover over these, you will see what the syntax is. So here you can use, for this delta symbol, you can write out increment. So INC will also get it for you. This is your gradient. So you can see here the syntax for that is nabla. And this will give you the radical sign, so the square root sign, but it's just the sign. You won't be able to put anything under that subscript. If you want to put together a actual square root, you're going to need to go over here to this radical button where you can see you have that dotted box inside of it. Okay, and you can also do your like cube roots, etc. And this is your common radical. So this is your quadratic equation formula for your roots. So in each one of these, you would have to do the same thing. You'd have to hunt and peck to find what you're looking for, insert it, then move your arrow key into those dotted boxes to start typing, and then hit enter, and then you do it again. It's okay when you're starting out, but I strongly recommend, it's why I'm making this video, that you move into LaTeX. So I'm going to show you a few more complicated equations and things that you can use LaTeX for in your equation editor. So let's start out with something simple. Let's start out with the line equation, y equals mx plus b. Let's throw in the slope formula from that. So that, you might remember, is m equals, and we're going to open up a fraction. And it's, remember, it's rise over run, or change in y over change in x. So let's write that out. Y sub 2 for our final, minus y sub 1 for our initial, close brackets for the numerator, and then in the denominator will be x sub 2 minus x sub 1, and then close brackets and enter. And there's our equation for slope. Let's go ahead and insert the equation of a derivative. So that's also going to be a fraction. And I just wrote it like that. Obviously, you can write it for whatever derivative you want. And let's do summation. All right, so I showed you the sigma, the uppercase sigma, and you might be tempted to use that sigma for what we typically use a sigma for, which is to show the summation. But there actually is a code for summation that I recommend you use instead, because it's designed to be a summation. So it will grow with your equation. If you have a large equation with fractions, etc., it will become bigger to fit all of those in, and just the sigma won't do that. It'll be that same little small looking sigma. All right, so let's open up equation editor again. We're going to do backslash sum. So that's how you call up the summation symbol. And as you may recall, on the bottom of the summation symbol, you'll typically have whatever your interval letter is and where it starts. So we're going to do the underscore, because that is going to be in the subscript area. We're going to open a curly bracket. We're going to say n equals 1, because I want my summation to start at 1. And then we're going to put at the top, because remember, the summation is going to go from 1 to whatever we say it's going to go to. So let's, for our superscript, say that this summation is going from 1 to infinity. So the code for infinity is infty, close brackets. So that will bring up the infinity symbol, which you can see here in the basic math menu. And if I hover over the infinity symbol, you will see come up the code for it. And now we can put in what would go inside our summation. So that is going to be x sub n. I tend to like to create spacing between syntaxes that I'm using, so it's easier for me to read. Most of the time the code doesn't need it, but it's easier for me to read, so I create those spaces. Like this didn't need a space between the closed curly bracket and the x to the n, but it's easier for me to read. So I do that, and then I press enter, and you can see here you have a much larger summation, or sigma, uppercase sigma sign, and you can see you have the n equals 1 and the infinity on top. And if you used this sigma here, it wouldn't grow with your equation, and you would get this n equals 1 not underneath the sigma, but to the right of it, and the same thing with the infinity. So I'll show you the difference. If I use uppercase sigma and then underscore n equals 1, and then superscript, open curly brackets, infty for infinity, close, and then x to the n. You can see it looks, this is not how it's supposed to look, right? We can all agree, we're all engineers and scientists, this is how it's supposed to look. So this is the right way. So for summations, you want to use the backslash SUM and then put in your subscript and your superscript so it'll look appropriate. Let's do some integrals. So let's start with a simple integral. So backslash int is going to create a single integral for you. And let's put in some limits of integration. So your bottom limit of integration, let's make that 0. And let's make our top limit of integration 1. So we're going to an integral from 0 to 1. And then what's inside the integral, let's say that's x squared. Okay, so we're doing a power. And then what we're integrating, what variable, so dx. And then hit enter, and there's your integral, okay? So you can do more than one integral, right? So we have single integrals, I just showed you, double integrals, triple integrals, closed integrals. So each one of those has a syntax as well. So let's do an area integral. Okay, I'm opening up the equation editor again. That's alt equal to get that open. And then I'm just going to start typing. So the backslash again, if I want 2 integral lines, I'm going to write IINT. And then I will put in this case, this is a generalized equation. So this is going to be underscore A for area. And you would have some function within that integral that has 2 variables associated with it. If it's a double integral, it's going to integrate over 2 variables. And then which variables you're integrating over. So that is going to be dx and then dy. And then you would press enter. And there's your double integral. If that's the way that you want to present it, if that is the symbology and the syntax that you want to use. If you actually want to show the limits of integration for x and the limit of integration for y, then you would do one integral, int, and let's say the first integral goes from 0 to 1 again. And then you would write your second integral, and let's say that one goes from 0 to pi. Then let's write our xy squared is our function, and then dx dy. So here you used the single integral int. Then I placed in the limits of integration for the first integral and then the second integral. And you would start here with the x first, so this would be the inside integral, and then the outside integral, that would be your y. Okay, so I'm gonna go backwards. I'm gonna do an undo so you can see the syntax one more time for this. So this is backslash int, that's the single integral, that's the one we did here. Then I'm gonna place in my limits of integration for that first integral. Then I'm going to add in the second single integral, backslash int, and then I'm adding in my limits of integration, right? What I'm integrating over. So in this case, the second integral will go from 0 to pi, all right? And then I'm going to put in my function, so space and then my function that I'm going to integrate over, right? My f of x and y. In this case, it's x times y squared. And then finally, what I'm integrating over, dx dy. And when I get all the way through that, you can see as I'm typing, right, nothing's changing. You're not seeing any change to the final version of what we're looking at. And press enter, and that's what you see at the end of it, okay? If you want to show a triple integral, okay, alt equals 3 i's and then the nt. And this would be for a volume integral. So it would be a function of 3 variables, x, y, z, as one option. And then right? dx, dy, dz, press enter. There's your triple integral. If you wanted it to look like this with the limits of integration for each individual integral, then you would do the same thing. It's just you would do it 3 times. So backslash int, first set of limits of integration, backslash int, second set of limits of integration, and then backslash int, third set of limits of integration. And then you would introduce your variables, or your dx, your dy, your dz. But you can write it however you want to, depending on, right, how you're writing out your math. So now let's do the closed integral. So a closed integral is an integral that has that circle through the middle of the integral sign, right, which implies a closed loop, like for a circle. So you have a closed path, right? That's what a closed integral is. It's a closed path integral. So you probably would have seen this in any of your Calc 3 multivariate calculus, your calculus-based physics, and any of your higher level classes that use calculus in them. So here, instead of an I to start, it's going to be a lowercase o. So that lowercase o is going to tell it to put that circle in between the integral sign. So O, int, and then you would do an open curly bracket, and typically closed integral, but not always. I'm just using an example here of an equation that you would have probably seen. So I'm going to introduce some new symbols here. So I'm going to introduce the vector symbol, okay? So when you have a variable that's a vector, right, you have that vector sign over the top of the letter. So to create that, you use backslash VEC, and then you open a curly bracket and write the letter that you want the arrow to go over, close curly bracket. And then let's introduce another symbol. So this is the dot product. So to get the dot product, you do backslash C dot, okay? And then let's do one last vector here. Because a dot product is a vector multiplication. So both sides, on both sides of the dot product, we have to have a vector. And then let's close the curly brackets. So everything within this most outer curly bracket belongs with the closed integral symbol. And then press enter. And voila. If you don't use that first set of curly brackets right after the OINT, okay, if I just write it like this, then you see you get this dotted box. So basically what this is telling you when you see this is that it doesn't think that what you wrote here belongs with this integral. It thinks that what goes in this box belongs with this integral symbol. So I'm just going to do some backwards. By adding in the curly bracket sign, it tells the computer that everything inside this curly bracket belongs with this symbol, and it'll put it inside, basically, if you can think about it as it puts it inside that dotted box so that it looks clean. Because what we don't want to do is have to go back and copy and paste and move something in. So when you are doing any of these long equations that have multiple things, the vector signs, let's add in times here. This will give you the cross product. And it really can never hurt to do it that way, to put those curly brackets in there. They might be superfluous at times, but they'll never hurt you if you add them in to just kind of encapsulate everything that belongs within a given symbol. So you saw if we go, it was here, the quadratic root equation. So this would be something that you might not necessarily want to type out. You could just click on it and then it shows up. And what we could have done is already write x equals. But you could also type it out. So I'm going to show you how to type it out because there's some useful symbols in there that I want you to see. So we would do x equals, we're going to have a fraction. So we're going to need to put everything here in the numerator. So open curly brackets, minus b. We need the plus or minus sign. So that's going to be backslash PM. That's how you get the plus or minus sign. Then we're going to have our square root, open curly brackets. And now everything inside this curly bracket will go underneath the square root, close curly brackets. We need to close the curly brackets one more time in order to close out our numerator. So this first curly bracket closed out the square root. The second curly bracket closes out the numerator. Now we open up a second set of curly brackets for the denominator, and that's a lot simpler. That's just 2 times a. Close curly bracket, and then press enter. And let's summarize what we've talked about here today, because we went over a lot of stuff. So I want to kind of summarize why I think the graphical user interface isn't as powerful as typing things out in LaTeX. And the first is speed. Again, you're already typing. Your fingers are already on the keyboard. We don't want to be moving our hands off the keyboard the least amount of times we move our hands off the keyboard, because every time you move your hands off the keyboard, and when I'm saying off the keyboard to move to the mouse, then that's slowing down your thinking, it's reducing your speed as you're typing, and it's taking just longer to do things. You want the precision. So this is the precision of how your math looks. And there is a slight learning curve, but you have the graphical user interface there to lean on as you're learning. But I will make the argument that the learning curve is not as steep as you think it is, because I think that most of the syntax that you're going to use is going to be fairly intuitive, and more often than not, something you've probably already typed out at some point, or very similar in wording to what it is that you're trying to write out. And it is scalable. So from writing in LaTeX in your Microsoft equation editor, again, you can now take that to more advanced LaTeX tools where you can write your entire document within LaTeX. And what you will see in the later lectures in this series is how powerful LaTeX is, not just for writing equations, but for actually typesetting your documents. You probably have experienced, if you've used Word more than once and used it for a complicated document, that it can be incredibly frustrating to format, and to format consistently as you're editing or, changing things around and moving things around. LaTeX doesn't do that. So stick with me as we go through this series, and I'm hoping it will increase your speed with which you are, and efficiency and professionalness of what you're writing. So what's next? We're going to move beyond Word, and I'm going to take you into full LaTeX. So that's going to be through Overleaf.com. So that is a free editor for LaTeX, and I think very powerful. It's what I use, and I highly recommend it, which is why I'm teaching it. And I'll show you how you can do both rich text and source code views within LaTeX. So even Overleaf has some graphical user interfaces that you can lean on, so you don't have to be fully proficient in LaTeX right off the bat as you go into Overleaf. And I also think Overleaf has really, really good tutorials. It has templates and really good teams to support you when you have questions. Then finally, I'll show you how you can create collaborative writing for research and reports. So how you would collaborate on a LaTeX document to make changes and to submit reports and submit documents through LaTeX. A lot of journals will allow you to submit your peer-reviewed journal articles for review through Overleaf in LaTeX format. So down here, there's a link, and this link will also be provided within the description below for this video. And it will provide for you a lot more of those symbols and syntax for math. So this is about 2 to 3 pages worth of math symbols in LaTeX syntax. And I think it's a really good kind of primer to have with you while you're starting to learn. So I want to thank you for watching today's video. Please remember to like and subscribe so you can be notified when my next video in this series drops. And I welcome comments and questions. My email is also provided below if you have questions as you are beginning to learn LaTeX. And thank you again for watching.